Hey guys, so we are going to be working on notes 4, which is your Pythagorean identities. So if you will just kind of look up there at the top, we're going to review what we covered yesterday, and then we're going to learn a couple of new ones. So first thing, remember that cosecant is the same as 1 over sine x. Secant is 1 over cosine x. Remember that tan is sine divided by cosine, and that cotan is cosine divided by sine. Okay, so those are the 4 identities that you should kind of already know, even back to the unit circle. All right, so the first identity is that sine squared plus cosine squared equals 1. I don't really want to get into it a ton, but it comes from the unit circle. Okay, so remember how we had like our perfect whatever unit circle. Let's say that you were here, we would draw the little triangle. Okay, remember that the x was always cosine, and then the y was always sine. So think about, if I did the unit circle here, this is my cosine x side, this is my sine x side. They're basically just doing Pythagorean theorem. And then I don't know if you remember on the circle, but what was this point? 1, 0. What was this point? 0, 1. Okay, this point was -1, 0. And then this point down here was 0, -1. So if you think about it, it makes sense that my x is a cosine, my y is a sine. So that means that those have to be equal to whatever this is, but that's 1 because this is a circle. And you can see that all of your radius distances are 1. So it doesn't matter if you're here in the circle or at one of the edges. Okay. So anyway, kind of fun fact, but that comes from the unit circle. Okay, you're just doing Pythagorean theorem. That's why it's called the Pythagorean identity. Okay, so so the good thing about this identity is that it actually gives us several other identities. So we're going to prove this one, but you could do it with any of them. Okay. So first thing, I'm going to start on, let's see. Yeah, let's start on this one. So we're going to start with this side. We want to make it look like that. So remember that tan squared, okay, well, tan is the same as sine over cosine. So if I want tan squared, then I want sine x squared over cosine squared x plus 1. That's what I have so far. Okay, so tan is sine over cosine, then tan squared is sine squared over cosine squared. Now, one thing you may notice that the squared is kind of in a weird spot. That's very common for like upper level math. They're going to kind of like tuck the squared in there before the x. So if that's weird for you, it is on purpose, and that's how, you know, it'll be pretty much always. So the next thing that I'm going to do is I'm going to get a common denominator. So I'm going to notice that here, if I go ahead here and put a cosine squared x on bottom and a cosine squared x on top, okay, then now I have basically one big equation here. So since my denominators match now, I could write that as sine squared x plus this is 1 cosine squared x. And then all of it now, since these match, I got a common denominator, is cosine squared x. Okay, so I went from tan squared to sine squared over cosine squared. Then I got a common denominator, and now I'm grouping it all together. But then look, your Pythagorean identity says that sine squared plus cosine squared is the same as 1. Well, then that means that sine squared plus cosine squared on top, all of that is really just a 1. Well, 1 over what? 1 over cosine squared x. And what is 1 over cosine the same as? Bam. Secant squared. Check. We did it. Okay. All right, let's take a look at number 2. So it says, prove that this side equals that side. Well, I see parentheses, so I'm going to go ahead and distribute. Okay, so 1 times 1 is 1. 1 times minus cosine A is minus cosine A. Now we're moving on to this guy here. Cosine A times 1 is plus cosine A. Now you could write the 1 here if you wanted to, but you don't have to. And then for my last one, I have a plus cosine A times a minus cosine A. So the plus and the minus give me a minus, and then cosine times cosine becomes cosine squared A. Okay? Then from there, I notice that negative cosine A and plus cosine A can cross out with each other. So then all that I have left is 1 minus cosine squared A. Now remember, I'm trying to make it this side look like this side. So I want it to eventually become the sine squared A. Here's the next thing that I'm going to do. If I see a sine squared plus cosine squared, I can turn that into a 1 because remember, that's the rule, right? I can also do that backwards. If I have a 1, I can turn it into a sine squared plus a cosine squared. So I'm going to take my 1 from right here, and I'm going to expand that into a sine squared plus cosine squared. So my 1 is now a sine squared plus cosine squared, then minus cosine squared A. And now, dun, 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 bye-bye. All that's left is sine squared A, which is, check, exactly what I wanted to get to prove it. Okay. All right, let's do another one. So next one I see here, I have a cosecant on the outside. So I'm going to go ahead and distribute that into both. Actually, first, well, yeah, we'll distribute first. So I'm going to have cosecant x is now going to be multiplied by sine x. So I'll have cosecant x sine x minus cosecant x sine cubed x. And then I'm like, oh wait, this is one of the properties. Remember, cosecant is a 1 over sine minus, oh wait, hold on, I forgot the second little sign. So it's 1 over sine x times sine x minus 1 over sine x times sine x, sine x, sine x. Now question, why am I writing that 3 times? Well, because it was cubed, right? So I really have 3 of them. Well, sine and sine can cross out. Sine and sine can cross out here. And so then at that point, what I'm left with from my first term is only the 1, because this 1 over sine from cosecant and regular sine, those crossed out. So I just have a 1 left over from there. Minus, these guys are gone, but I have 2 sines left, so I could call that sine squared x. And then remember, I want it to come out to look like this. Well, then I'm going to come back up to this rule. What is 1 really equal to? 1 is really equal to sine squared plus cosine squared. So I'm going to take my 1 from right here, and I'm going to replace that with a sine squared plus cosine squared. And then I forgot we're supposed to be on x mode now. So my 1 is now sine squared x plus cosine squared x. And then I have minus sine x back behind that. And then I'm like, oh, wait. And actually, it was a squared. And I'm like, oh, wait, look at these guys. Sine squared minus sine squared, bam, bam, gone. What's left over? Only cosine squared x. Got it? So good. All right, turn the page. Three more left. Take a look at the next one. I have cosine squared minus sine squared equals 1 minus 2 sine squared. So first thing that we're going to want to do here, we can pick whichever side we want to start with. So let's go ahead this time and start on this side, because I think that might be easier. So I'm going to first take, so again, I'm starting with this side. I want it to eventually look like that. So I'm going to do 1 minus 2 sine squared x. Well, the first thing I'm going to do is take my 1. I'm going to split that up into a sine squared x plus cosine squared x. And then minus 2 sine squared x. So the only thing that happened, this is now the same step I did on those other two, is I'm taking my 1 and I'm replacing it with a sine squared plus cosine squared. Okay, then the next thing that I'm going to notice is that these don't actually cross out, but they can combine. So if I have 1 sine squared minus 2 sine squareds, those are like terms. 1 minus 2, okay, that's going to give me -1. So now I'm going to have -1 sine squared x plus cosine squared x. And then I'm like, oh, look, these are the same. Okay, the only difference is instead of putting the -1 here, they just reverse the order. So my cosine squared x is going to come first because it's positive. And then my minus sine squared x is going to come second. But remember, you can reorder numbers. Doesn't make a difference there. Okay. All right, go ahead and turn the page for me, please. Next one says tan x plus cotan x equals cosecant times secant. So let's take a look at that next one. So let's see, which side do we want to start on? Let's start on this side. So I have tan x plus cotan x. So the first thing that I'm going to do is I'm going to break both of these down. So I know that tan is really the same as sine x over cosine x. But then I know that cotan is cosine x on top, sine x on bottom. Okay, so I'm starting with this side. I want to make it look like that. Okay, so the next thing I'm going to do is I'm going to try to get a common denominator, which is exactly what we did last time. So I need these bottoms to match. So in order for this one to match, I need to give it a sine x. Okay, but remember the rule is you can't only put the sine x on the bottom, you have to put it in both places. So now on bottom, I have a sine and a cosine. Okay, well now look at this fraction. I already have the sine. What does this one need though? It needs to match here, so it needs another cosine. Okay, so now what do they both have on bottom? A sine x and a cosine x. So I can make one big fraction, sine x, cosine x on bottom. But here I have a sine and another sine, call it sine squared. Then I have a cosine and another cosine, that's cosine squared. And then from there, what is sine squared plus cosine squared equal to? Okay, all of that is equal to 1 over sine x, cosine x. And then remember, what's 1 over sine called? 1 over sine is called cosecant x. And then what is 1 over cosine called? You can even give it another 1 if you want to. Okay, 1 over cosine is the same as secant x, which is, check, exactly what we wanted from the beginning. Okay. All right, last one. Number 6. So I see we have some cosine, secant, tan, and sine. So let's flip back over here for a second. So we've used the sine squared plus cosine squared rule a bunch of times. Have we done the tan and secant rule? No, we have not. So I want to just point out, like I told you, you have this one, which we've now used a couple times. You also have these two as well. Okay, so I'm going to write rule number 2 on the back side so that we can use it for this last question. So it says that tan squared plus 1 equals secant squared. So I'm just going to write that over here to the side. Tan squared plus 1 equals secant squared. Then I really should have x's in there. I forgot it. Okay, so last question. Let's work this side out. Okay, so I have cosine m minus secant m all squared. Okay, so last question. Number 6, we're showing that cosine m minus secant m squared equals this side. So I'm starting here. So I'm going to have cosine m minus secant m. If that's squared, that means I can really write it twice. Okay, so first thing I did is I squared that. Second thing I'm going to do is double distribute. Okay, so I'm going to do my little arrows here. So I'm going to have cosine m times cosine m. That's going to be cosine squared m. My second arrow, cosine to secant. Okay, then remember, after I distribute, I come over to secant, and I'm going to distribute that one twice. So for my next arrow, it's secant m times cosine m. And then for my last one, I have negative secant times negative secant again. That's going to be a plus secant squared m. Okay? And so when I worked this the first time, which obviously I'm going to cut out of this video, this was the mistake I made right here. If I multiplied two negative secants, I should have gotten a plus secant squared. But whoopsie-daisy, I accidentally did a minus secant squared, and then it ended up kind of like just messing everything else up. So that is why your video is like awkwardly cut, because I messed up. Okay. So anyway, next step. So I have my cosine squared here. And then for my next term, I have my cosine, which is fine. But then secant is really a 1 over cosine m. And then what I notice happens is that those guys are basically going to cross out and just leave me with a -1. Exact same thing's about to happen here. When I move over to this term, I have my minus. Remember, secant's one of my rules. That's 1 over cosine. But then I also have a cosine m. Those guys can cross out as well. So really, I have a -1 here, and then another -1 here, and then plus my secant squared from the end. Okay, so now this is what I have so far. Cosine squared m minus 1 is really a -2, and then a plus secant squared m. Okay, so far so good. Now we're going to use the second Pythagorean rule that we wrote over here onto this page. So remember that secant squared is really equal to tan squared plus 1. So I'm going to take my secant squared from here, and I'm going to cross that out, and I'm going to put in a tan squared plus 1 in its place. Because remember, what is secant squared equal to? Tan squared plus 1. Okay, so now I have cosine squared m. Okay, now my next term, I'm going to go ahead and combine this -2 and this +1. If those are both numbers, I can just combine like terms. So -2 plus 1 is really just a -1 here. And then don't forget, I still have my plus tan squared. Okay, but then the very last and final step I'm going to have to do here is with this -1. Remember this rule over here that sine squared plus cosine squared is 1. I'm going to replace the 1 with a sine squared plus cosine squared. So I'm going to use this side and replace it where my 1 was. So I would say I have cosine squared m minus, and then where my 1 was, I'm going to do sine squared m plus cosine squared m. And now hopefully you can see, now that I've replaced that 1 with a sine squared plus cosine squared and minus cosine squared, because remember that minus applies to both of those, is going to cancel that guy out. To where all I'm left with is negative sine squared m plus tan squared m. And notice that's the exact same thing as this. The only difference is that they reverse the order. So my last step, hopefully you wrote smaller than me, is tan squared m minus sine squared m, which is check, exactly what we wanted from the beginning. Okay? So go ahead and take a look at your homework. You'll notice you have 10 questions. Okay, so I'll work a couple of them with you just to kind of get you started on it. So you're looking at homework 4. Let's see what we can do here. Let's start with one of the true false. And just keep your notes out because you have all those rules on here, right? So just look at your first section. Okay, if I had, let's do just A, 1 minus secant squared. Okay, well, let's think about that for a second. I know that secant squared here is the same as tan squared plus 1. So if I take my secant squared and I replace it with tan squared plus 1, let's see what happens here. So here's my secant. I'm going to do 1 minus, and then where my secant is, I'm going to plug in tan squared plus 1. Okay, so I did 1 minus. Okay, then this negative is going to have to get distributed. So I have 1 minus tan squared x, and then my minus on the 1, and then 1 minus 1 is going to cross out. And then all that I'm left with is a minus tan squared x. But they said I'm supposed to have tan x, so I would say that that is false. Okay, this one should obviously be false. Remember, it's not sine squared minus cosine squared. It's supposed to be a plus. So if they have a minus here, then that is false. Okay, if it were a plus, though, that would have been correct. Okay, and then I'll let you figure out letter B. Okay, let's do maybe like 2 more. Number 5 looks a little bit trickier just since it has a fraction in it, so let's do that one. So I have secant x over sine x minus sine x over cosine x. Okay, so one of the tools that you learned in your notes is to get a common denominator. So when I see that these bottoms don't match, I'm going to want to fix that. So I'm going to put a cosine x here and a cosine x here. Now they both have a cosine, but this one has a sine, so I got to add the sine here. So I'm going to do a sine x here and a sine x here. Now I look at both of the bottoms. They both have a sine and a cosine, so I can split that up into sine x, cosine x. Okay, remember, once the bottoms match, you can put it together. Then right here on this side, I have a cosine times secant. And then here I have a sine times a sine is a sine squared x. Then from there, remember that cosine and secant is really cosine x times 1 over cosine x. And so those guys there can bloop, cross out. So that's really 1 minus sine squared x over sine x cosine x. And then my last thing that I would do there, well, almost last thing, is that once my cosine and my secant cross out and just give me this 1 left over, I'm going to replace that with my Pythagorean identity. So remember, what is 1 the same as? 1 is the same as sine squared x plus cosine squared x. That's replacing my 1. And then I have the minus sine squared x, and then over sine x cosine x. And then look what happens here. If I have a sine squared, remember all of this came in to replace my 1. Okay, so if I have that minus, these guys can cross out. And then I'm left with a cosine squared x, which is like cosine x twice, over a sine x cosine x. And then I can see that one of my cosines can knock off. I'm left with cosine over sine, which is the same as cotan x, which is check, exactly what we were hoping to get from the very beginning. Okay? So remember, whenever you have fractions that are added or subtracted like that, you're probably trying to get a common denominator so that you can get stuff to simplify. Okay? Let's flip over to the back, check out that side. Let's do number 8. Okay, last one. So we have cosine x secant x plus cosine cosecant squared. So let's start by distributing. Okay, and some of these you're just going to have to kind of like start off doing something and then just see what happens. So cosine times secant is cosine secant. Cosine times cosine is cosine squared, then cosecant squared. Then the next thing that I notice here is that if I have a cosine here, times a secant. Remember that that's one of your special rules. Okay, that secant is really the same as 1 over cosine. Okay, and then I can see that these guys are basically just going to cross out and leave me with a 1 plus. All right, now let's look at this one. I have a cosine squared here. And then cosecant is the same as 1 over sine squared. And then I'm like, oh, wait, well, if that's cosine squared and that's sine squared, okay, notice my cosines are on the top, my sine squared's on the bottom. Then from there, remember, what is cosine over sine the same as? Cosine over sine is the same as cotan squared x. Now, if sine over cosine, if it were upside down, that'd be regular tan. But since it's cosine on top, sine on bottom, that's cotan. And then from there, you can go back to your little notes here. Okay, what does it say cotan squared plus 1 is? Cotan squared plus 1 is equal to cosecant squared. And cotan squared plus 1 equal to cosecant squared. Okay, which is, check, exactly what we were hoping to get in the beginning. All right, let's see, maybe we'll do one more. Let's do number 10. So first thing I notice on number 9. First thing I notice on number 9 is I'm gonna have to start off by distributing. So if I do secant times secant, I get secant squared x. Secant times plus 1 here is a plus secant x. Then I move to my second term. Minus 1 times secant is minus secant x, and then minus 1 times 1 is a minus 1. Then from there, I see I have a secant x and a minus secant x. Those guys can cross out. So I'm left with secant squared x minus 1. Okay, then I can look over here at my little sheet. Okay, look what it says about secant squared. This is rule number 2. Secant squared is the same as tan squared plus 1. Secant squared is the same as tan squared plus 1. And remember that if that's replacing the secant squared, then I still have this other minus 1 from back here. Those guys can cross out. Then tan squared x is all that's left, which is, check, exactly what we wanted from the beginning. Okay?